It is Monday morning. Your engineering team is popping champagne because your new agentic retrieval augmented generation pipeline just hit a 98% precision score on the golden eval set. You solved hallucination. You solved context collision. But as the product manager, you are staring at a disaster. Your user analytics show that user retention has completely flatlined. Your users are abandoning the application after exactly 2 queries. Why? Because the system takes 7 seconds to generate an answer. You have built a perfectly accurate system that no one is willing to use. In the enterprise world, a slow answer is treated as a broken feature. Welcome to the 7-second churn trap. First, we have to stop the bleeding and win back user trust. To do that, you need to slash latency immediately without rewriting the entire backend today. You instruct your engineering team to deploy semantic caching at the edge. You place a vector cache, like RedisVL, directly in front of your LLM. If a user asks a question that is semantically identical to a question asked 10 minutes ago, you bypass the retriever, you bypass the rewriter, and you bypass the massive generation model entirely. You serve the cached answer in 50 milliseconds. Next, you force the front-end UI to guarantee token streaming. You cannot magically make the final synthesized answer arrive faster today, but you can make the time to first token drop under 1 second. If the user sees the model immediately typing, they will wait. If they stare at a spinning loading wheel for 7 seconds, they will close the tab. With the triage in place, we need to look at the architectural root cause. Why is this pipeline so incredibly slow? It is because your architecture optimized for academic benchmarks instead of human psychology. Your pipeline is strictly sequential. You built a linear latency stack. When a user submits a query, it takes 500 milliseconds for the embedding model to process it. It takes 1 second for the dense vector search to retrieve 50 chunks. It takes 3 full seconds for your heavy cross-encoder to re-rank those chunks. And finally, it takes 2 seconds for the massive enterprise LLM to read the context and generate the response. You stacked the latency of every single node in your directed acyclic graph, one after the other. You built a system that is mathematically accurate, but operationally unviable. Here is the architectural specification to ensure you never fall into the churn trap again. First, you write a hard time-to-first token budget into your PRD. Latency is not an operational afterthought. It is a core product feature. If the time-to-first token exceeds 800 milliseconds, your CI/CD pipeline fails the build, period. You must enforce an SLA on every single step of your pipeline. Second, you stop using massive foundational models for every single task. You must implement semantic cascading. You do not need a trillion parameter model to route a query or rewrite a prompt. You will deploy a lightning-fast, quantized 8 billion parameter model running locally for your routing and metadata extraction. You save your heavy, expensive API calls exclusively for the final synthesis phase. Finally, you mandate parallelized retrieval. Your subagents must fetch from the SQL database, the lexical search, and the vector database concurrently. If your re-ranker takes longer than 1.5 seconds to score the chunks, it times out and passes the top BM25 results directly to the generator. You implement circuit breakers on your retrieval nodes. High accuracy means nothing if your users abandon the session before the first token drops. Stop building RAG for benchmark leaderboards and start building it for human latency tolerance. Lock down your TTFT, parallelize your pipeline, and I'll see you in the next post-mortem.